All right, let's get right into it. Back in 2017, some researchers at Google dropped a paper with a pretty bold title. It was called Attention is All You Need. And you know what? That one paper completely changed the game for artificial intelligence. It's literally the blueprint for models like ChatGPT and, well, pretty much everything we see today. So in this explainer, we're going to break down exactly how they pulled it off.
So, before this paper, the entire world of AI had this one unspoken rule. For a machine to understand a sentence, it had to read it one word at a time, sequentially. That was just how it was done. It was the only way anyone thought it could be done.
But this whole one word at a time thing, it was a huge problem, a massive bottleneck, really. It was this fundamental limit holding the entire field of AI back. And that's exactly the problem the authors of this paper decided to tackle. The models they were using back then were called recurrent neural networks, or RNNs, and they worked pretty much like this. They'd read the first word, think about it, then move to the second word, trying to remember the first, then the third, trying to remember the second, and on and on. It's like a line of dominoes, right? You absolutely cannot get to the last one without knocking over every single one before it in perfect order. The paper calls this inherently sequential. And this whole sequential process had two major drawbacks. First off, it was just slow. You couldn't process the end of a sentence until you dealt with the beginning. That meant you couldn't really speed things up by throwing more computers at it. And second, these models had a terrible memory. By the time an RNN got to the end of a long paragraph, it had often totally forgotten what was said at the beginning. Connecting ideas across long distances was a huge, huge challenge. So what did these Google researchers do? Well, they proposed something kind of crazy. They decided to just take that whole sequential rulebook and, well, toss it right out the window. They were going to build something totally new. And this sentence right here, this is where everything changed. I mean, just listen to how bold this is. They're proposing a new architecture, the transformer, built only on something called attention, and then the killer phrase, dispensing with recurrence entirely. They weren't just trying to make the old way better, they were getting rid of it completely. So what did they replace it with? This is where the magic really happens. They used a mechanism called self-attention. This is the engine that powers the transformer, and it's the reason modern AI can understand context in a way that was just impossible before. Which brings up the big question, right? How can you possibly get a machine to stop reading like a machine, word by word, and start seeing the whole picture, to understand the entire web of relationships in a sentence all at the same time, just like you and I do? Okay, take a look at this sentence. When you read it, you instantly know that the word it refers to the bee, not the flower. But for an old sequential model, that's actually a really hard connection to make. By the time it gets to the word bee is ancient history, several steps in the past. This is the problem that self-attention just completely solves. It's like a superpower. It lets the model look at every single word in the sentence at the exact same moment and figure out how important each word is to every other word. It learns that it is paying a lot of attention to bee and not so much to flower or nectar. This is the breakthrough. It creates this rich map of context, connecting words no matter how far apart they are. Okay, so now they've got this incredible new tool, this self-attention thing. So what do? They build an entire architecture around it, and they called it the transformer. So the paper lays it out like this. The transformer has what's called an encoder-decoder structure. That part wasn't super new, but what was inside, that was revolutionary. It was just stacks and stacks of these self-attention layers. And this is the most important part, no more recurrence. No more sequential one-by-one processing. Now every word could be processed at the same time, in parallel. Now, this table from the paper might look a little technical, but what it shows is an absolute quantum leap. See, for the old models, the number of steps it took to connect two words depended on how long the sentence was, what they call O of n. But with self-attention, it's O of 1, a single step. It doesn't matter if the words are next to each other or 100 words apart. It's one step. This meant models could now link distant ideas instantly, making them unbelievably powerful and way more efficient. The theory was beautiful, for sure, but did it actually work? Well, the results they published didn't just move the goalposts. They basically built a whole new stadium. So they tested their model on machine translation, which is a classic test for language AI. On the super tough English to German translation task, the transformer scored a 28.4. That was a brand new world record state-of-the-art score. And let me give you some context for why that number is so wild. The previous best score from all other models combined was 26.3, beating the record by over 2 full points on this scale. That just doesn't happen. It was a massive, almost unbelievable jump in quality from a single new idea.
But here's the real kicker. It wasn't just better, it was ridiculously efficient. On another big translation task, their model set a new record after training for just 3.5 days on only 8 computer chips. And this is the 1-2 punch that just blew the minds of the entire AI world. The transformer wasn't just more accurate, it was also way, way faster and cheaper to train. It was better, faster, and more efficient. I mean, it was the whole package.
So, as you can imagine, the impact of this paper was about way more than just a new translation record. It laid a completely new foundation for how we think about and build artificial intelligence.
The transformer wasn't just an improvement, it was a true paradigm shift. It forced the entire field to switch from thinking sequentially, one domino at a time, to thinking in parallel, seeing the whole pattern at once. This architecture is the direct ancestor of pretty much every large language model we have today.
In the paper, the authors conclude by looking ahead, talking about applying these same ideas to images, audio, and video. And today, we're seeing that happen all around us. It just goes to show you, sometimes the biggest revolutions start by questioning the most basic rules. And it leaves all of us with a pretty exciting question. If this is what attention did for language, what's it going to conquer next?